Hey folks, welcome back. We got this 1996 Chevrolet Tahoe in here, 5.7 liter, and it's got a really high idle. Matter of fact, it's not idling. It's sometimes gets up to about 2,500 RPM or something like that. It just will not go down. Obvious things to look for and things like that are, if these are too tight, make sure your butterfly valve is closing, which we've got it. That's perfectly working just fine. Looks like somebody recently has changed the idle air control valve there. And I mean, I know that's what they told me. And that hasn't cured the problem. Let's go ahead and fire this thing up. There, just started it up. There it goes. Gets a little worse than that too. All right, so one of the things that other things that cause this issues and stuff like that you have to know whether you don't have are intake manifold leaks and or vacuum leaks. I went ahead and pulled this vacuum line off right here, the brake booster, and ran my smoke machine in here and didn't find any leaks. The other thing we can do is we can unplug the idle air control valve here and take it out. There's two T20 Torx screws. One's hard to see, but you can see one of them's right there. Kind of got that little bit of white paint-ish stuff on there. Get that thing pulled out. All right, obviously this is brand new. What you can do, you can pull this thing out. I wouldn't say all the way, but just a little bit. And I'm gonna get that stupid deal on there. That's what this, this plunger closes off into. That's the other thing too, is you got to make sure that hole in that spot in there is all clean and everything like that. With this thing, retracted all the way back, we know that we're letting way too much air into here like this. So we'll pull this thing out just a smidge, and then we'll reinstall it again. Don't plug it in. All right, so we got not plugged in, reinstalled, not plugged in. So now what we'll go ahead and do, start the car up again here. Idle's, maybe it's just a smidge higher would be better, but so. Yeah, you can actually take it like this, and you can take it out and drive it, and it'll run fine. You don't want to leave it like this because that valve is just a little bit open. We're still getting a little bit too much air in. It's just not as much as before. So now we can go ahead and plug this thing back in. And you can see our idle's coming up just a little bit. There it goes. This is not me pushing on the gas. This is what it's doing. Okay, so one thing we need to do, this kind of gives you some ideas. Basically, what that kind of did was the first time I plugged it in there, this thing wouldn't start until you pushed on the pedal just a little bit, opened up the butterfly valve, and then it started up and ran just fine, but then as soon as you let off, it wouldn't run. So I pulled it back out again, pushed the little plunger thing back in just a tiny bit, and that's where we have it right now. So I'm going to do that again and then leave it unplugged, and then we're going to grab a test light and we're going to be checking for some grounds on these particular wires right here, and go from there. So then I'll explain what we're checking and everything like that. So okay, so we're back to where we were there. Got the idle air control valve back. You know, I pulled that plunger back out a little bit farther. Got this thing where the engine's not sitting here running at 2,500 RPM, and still got it unplugged. So now it's gonna, it's gonna idle just fine. Like I said, with that test, kind of also tells a little bit about the fact that we don't have like any big leaks going on or anything like that, because we can get this engine to idle down by manually moving the valve closed and everything like that. So next check that we need to do is we need to get a test light. It's got to be a test light. The best test lights are the kind with an actual bulb in here. I don't like using any of those LED ones or anything like that. Just something that's going to actually pull a current. And you're going to hook the one lead onto your positive battery terminal, and then we're going to start the car, and we're going to go through, there's 4 terminals on this plug here. We're going to go through each individual one here, and the test light's either going to be on or it's going to blink, depending on, and what you want to do is each time you put it on one of these terminals, you see what the test light's doing, then rev the engine up to various different RPMs, up, then down, and the test light's going to change, and it's going to do that. The main thing is we want the test light to be on at some point, idle or having the engine revved up or whatever, on all 4 of those terminals there, because that's how the computer does what it needs to do to change that particular the idle air control valve and everything like that. It's a stepper motor, and it goes up and down and back, so we want to check, make sure we got proper ground and all that, or proper wiring all the way there to the they're calling it a vehicle control module. A lot of times we call it a PCM, powertrain control module nowadays, but they're calling it a VCM in here, and this is it right here. And so let's go ahead and we'll get that test done. Okay, so we have the test light right here on positive lead here, so that where you touch this thing to a ground, it lights it up, just like that. So now we're going to go ahead and going to go through each individual one of these. I had to change the camera angle a little bit to get it where you could see everything. All right, so we actually are missing this right here on this particular terminal, which I believe if I were to hold this thing like this. Let's have a look at the schematic. Okay, so that is terminal A. If you hold the connector with the clip right here, it's terminal A. It is a blue, light blue with a white tracer on it. This right here, the next one in is a light blue with a black tracer. Then we have light green with white, and then a light green with black tracer there. I was looking at the schematic here, and so right here, like this schematic is different than this, and it also, you can see how it's got where both of them, C and D, both black or light blue with white, light blue with white. So you're going to run into that with aftermarket schematics. Terminal A, you know, that's what we're not, you know, but everything should be close enough here that we can go in here and find these terminals and find out which wire does what, because I believe this wire color is correct in this terminal 14 right here. This is the vehicle control module, VCM, and so it's in connector C2. See right there, there's connector C1. So C2 is going to have all the connectors in there. So we need to get that thing unhooked, and we're gonna do an ohm check right quick, and I will explain to you why the ohm checks are not the best way to do it all the time. We're gonna do that quick, just you know. And so here is the connector here, and so you kind of just lift up right about here. Let me see if I can get a screwdriver and kind of just, if you lift this up some, and then that just kind of slides off of there, then you can push this down with your thumb and unplug this thing. Now this isn't the connector that we're after. The one we're after is down here below this one. Yeah, and then this just slides right back into place there and just locks it. So this one you'll have to reach underneath here. I can get it with the tip of my finger, and I've already got it off of there, but I don't know if I'll be able to show this or not. But anyways, we're gonna get this unplugged. I'm gonna need both hands to do all this stuff. Okay, so when I was actually looking at it, I was trying to look into Mitchell and stuff in here, and I was trying to find the actual connector pinout, you know, deal, and I couldn't find it. So basically I just looked on here and was like, okay, this is a 32 connector, 32 pin connector, which, you know, I think this one is too, but obviously this one is not, so that eliminated that one. This I think is bigger, but anyways, I started with this one. Obviously it wasn't a 32. Got to this one here, and then right in here, if it can be seen, you can see that there's a 1 and a 16. Well, 16 is half of 32, so, and then on this side you've got where it says 32 and 17. So basically terminal number 1 is this terminal, if you're looking at it like this, which is bottom left side right there. And then this is terminal 16, bottom right, and then over here you're going to have 17 all the way to the top right corner, 32. So we got the right connector. So now what we're going to do is get an ohm meter. All right, so we're going to test the first one. We're going to test the two green ones right here. So we're going to test this light green and black. It's all the way down here to terminal 29, light green and black, terminal 29. So then what I do is remember which side we were on here as far as 32. So then what we're going to do is count 32, 31, 30, and 29, fourth one over. Okay, and this particular meter reads OL when you got the leads here until they touch. So we got 0.02 right there, and I'll actually put my beeper on here. If I can remember how to do it. There it is. Now what we do is, if this wire is good, so then we'll come in here, and the green and black wire is the one that's farthest over here. Okay, so that wire is good. Well, to a point. That can deceive you a little bit too. So the next one we're going to do is this green with the white tracer, which goes over here to terminal 13 right there. So then we're back on the other side of this plug, which we are 16. So then we're going to go 16, which is the far out one here, 15, 14, and 13. We'll stick the probe in there, and then we'll go to the next wire in, which is from this way. All right, that one's showing that it's got a connection through there. So now we're going to go ahead and do this light blue with white, but remember these are different, so I can't remember exactly which, but it's terminal C. We're going to go over here to follow this all the way down. That is going to be terminal 30. The next one we're going to do right after that's 31. So terminal 30. So come over here, and we got 32. 32 here, 31, 30. Okay, then we're going with the this is the wire with the blue wire with the black tracer on there, which I believe was correct on the first schematic we looked at. Okay, so that wire is testing good. Yeah, which is light. So this particular schematic's correct. This one here they got a little bit wrong, but it's still useful for us though, because the wire connections are the same. They just have them labeled wrong. So now what we're going to do is this one that's highlighted here, which is the dark blue with the white tracer. Terminal 14. I said 31 was going to be the one I was doing before, but that's not right. I don't know which one I did. Anyways, we're over here to 14. So we are back on this side. So 16's all the way over here. So we got 16, 15, and 14 right there. And we're at the farthest one over here, the one wire that did not have the test light, and we don't have anything there. An ohm check is good when you have a purely open wire between here and here. If you have a bad wire that might have some high resistance or something like that, you can still get an ohm check to test just fine. But once you start flowing current through a wire, then it can open itself up, and you take the current away, and then it closes again. That happens all the time. That's why using a voltmeter or using a test light instead of a voltmeter when you can, and actually test circuits, you're going to be a lot better off, because the test light can actually light up. You know that circuit, you know, because I've measured power on a wire before, and you measure power with the voltmeter, 12.5 volts, perfect, everything's good. You put a test light on that same circuit, and the voltage dropped to 0 because now you put a load on it. So that's we can't test the integrity of the wire there. So what we're going to do now is we're going to back probe into here and on both sides of this terminal here. And we're just going to connect a jumper right across there and see if we can get this thing to, you know, bring the idle back down, because that's pretty sure that's got to be what's going to happen. You know, because we found this open wire, so in between, you know, here and here. If all of your ohm checks and everything were fine on here, you know, between all four of those wires, you would still have to check the integrity of the wires. We're lucky that we found an actual open, so that we know which wire we're gonna jumper back and forth between this plug and there. So let's get that all set up. Okay, so ideally, well, we got our back probe in on that wire there, and then I did it right in here. You can kind of take these things apart a little bit. I don't know if I can be able to show it. Almost like a clamshell in a way. Get in the back of there. So ideally, that wire is indeed bad. What I got is the two jumper wires, you know, because my back probes kind of look like this. You got a little back probe right in here to an alligator clip jumper wire. There's various different types of, I just have these. And so we got it up in there. So all we need to do is theoretically put these two wires together. So we're going to fire the truck up and start it up. The idle should start climbing up and up and up, and hook these two wires up, hopefully, and hopefully it will come back down. That's the goal. A little high at the moment, but she's coming down. Takes a little bit. I don't know if I got the greatest connections on my back probes and stuff there, but just watch what happens when we well, I don't know if you can hear very good. Just watch what happens. I'm going to unhook those wires, those two alligator clip wires, and just watch what happens there. If they rev it up again, it'll go higher, but we're gonna shut it off for now. All right, let's see what's going on here. All right, so, well, what's going on here? Well, we got an open wire between this point and this point right here. Bad wire somewhere. We're gonna try to do what we can to find it. I think the first thing I'm gonna do, well, I'm not sure about. We just need to try to find it, or you know, if it's your car, you can run a whole new wire from over here to there or something like that. This thing, I think we should try to find it. But anyways, what's going on? Well, that wire's open. The reason we did the test light trick on the plug in here, you know, was because this computer has got some, I think they're called transistors or something like that, and it goes back and forth between, though, that's why the light blinks, is because it's switching back and forth between ground and a positive source, back and forth, all different times to control that motor plunger stepper in and out of there. Well, what's going on is each time the engine either goes down or revs up, that motor tends to suck in, but it can't go back the other way because that wire is open and it's not being able to. So when we provide the path between this point and that point, then it can control itself. And so therefore we've got the you know, on the way to getting the problem fixed and everything like that. So hopefully the, you know, the test light test basically did the best out of anything, because we didn't have nothing on that particular wire there. And then you know, I guess one other thing we could do is we could unplug the let me see, we can unplug the plug here and go back with the test light and confirm that we've got blinking power back there or whatever. But we pretty much know that by now, by unplugging the, you know, or plugging these things back up here, we can get the idle to control back down, you know, and run it. And then as soon as we unhook this, then it goes right back into what it was doing before. Like I said, it's kind of complicated sometimes to understand about, like, you know, the ohm test and using a meter. A meter has its place. A test light has more of a place, in my opinion, for, you know, different things with, you know, auto electric, especially when you're dealing with just 12 volts and grounds and stuff like that. You know, because had we have seen that we had a connection through there, we would have had to do a little bit test further. And sometimes what I do is I'll unplug both sides and I'll feed a power probe into the other side, and then I'll just ground it or jump it or whatever, and I can check the integrity of one or two different wires or something like that just by applying 12 volts to a wire. You got it unhooked on both ends, so you know you're not going to hurt nothing, and that'll be one way to do it. But in this case, we used the ohm check. We saw that we had an open, so we know 100% that the wire's open. If the ohm meter says it's open, then we know we got a bad wire there, and that's why we went the route we went. So hopefully this helped you out some, and thanks for watching.